Okay, so now that you have practiced a lot of graphing stuff, we are going to talk about inequalities again. And it says, already done this, so why do it again? Well, because inequalities come in different forms, everybody, different forms. The form that you already saw would be like x is greater than 3. What we've seen in the past is an inequality where we have one variable and our symbol, and then a number, and then we do a little shading on a number line, right? 1, 2, 3. Remember an open circle, and we would shade to the right. That's what we've done before. But now, what about when you have two variables? So, in other words, what if it looks like instead of y equals mx plus b, what if you do have y is less than or equal to mx plus b? So there's two variables. There's an x and a y. And now instead of graphing on a number line, we are going to graph on a coordinate plane. So we're still going to be doing shading. We're still going to be doing open and closed circles. It's just not in this little one number line. Now it'll be on a coordinate plane. So how do we do that? Well, first there's a few things to keep in mind. We are going to, anytime we have a function, no matter what it looks like, let's say it's like, ax plus by equals c. So I've just made up a bunch of letters here, okay? The a, the b, and the c are just numbers is what I need you to understand. If you have this is not what you want your function in. Put a big slash through this. We do want ours to be y equals mx plus b. Okay, so just like the video last week and the video the week before, this is what you want. Now, in here, there's going to be some sort of a symbol, so I'm just going to draw a big open thing, but there could be less than or greater than or whatever, okay? But you definitely need y equals mx plus b. I also want to remind you from a few weeks ago, with an inequality, what happens when you divide by a negative, okay? So if dividing by a negative, negative 3y. Let's do something like this, less than 9. Remember that when you get to that step where you have to divide the negative off, the minute you do that, it switches that sign in the middle. Okay, you have to flip the inequality to the other direction. And then the other thing I want to remind you of over here is the solid versus dashed and where to shade. So this is going to be a little different because the only thing you had to worry about before was an open circle or a closed circle, okay? And that's whenever we were on a number line. But what's going to happen now is instead of just graphing on a number line, we're going to actually have a graph that may look something like that. Or it may be a dashed line instead, and that's what I mean here by solid versus dashed, okay? What's going to happen is if you see less than or equal to or greater than or equal to, it's like the solid dot where you're going to have a solid line, okay? But the open circle is if we had greater than or less than without the equal to underneath. And that's whenever on this type of graphing, you're going to do a dashed line, okay? It's going to look something like that. So that's the difference between dashed and solid, is depending on the symbol that you see here, okay? I'll kind of box these together. All of this goes together, and all of this goes together. So just check your symbol whenever you're doing that. And as far as where to shade, it's really kind of easy, guys. If you see greater than or equal to, you need to shade above the line. If you see less than or equal to, you need to shade below the line. And we're going to do examples so that that part will make sense. But don't make it harder than it is. It really is just greater than, above, less than, below. Okay, example time. This should hopefully make it come together. We're going to graph this. First thing is, I just pretend that's an equals and I do this part. Okay, now it's already mx plus b, and that's what we want. So the b is -1, which means I start at -1. and my slope is 2/3. So up 2 over 3, up 2 over 3. Okay, great. So now I have to decide, do I connect the dots with dashed or with solid? Well, you look at this symbol, and since it is strictly less than, there is no equal to underneath. That is dashed. So if you haven't memorized that, just look above in the notes. So we're just going to have a dashed line that goes through all of this. And then we have to do shading because the dashed line doesn't tell me enough. Instead, it just shows me that matches that symbol. So for less than, I need to now shade below the line. Y is less than all of that, so shade below. What you guys are finding, just so you know, what this means is that every single point that's inside the green shaded region, if you took that point and if you plugged it in up here, it would be a true statement, okay? So that's kind of cool. So let me give you an example. Let's just pick any point in here. Let me pick this point. Okay, this is the point 40. So I'm going to write, I'm checking myself here, the point 40, right? Now, if I take this point 40 and I plug it in up here, what that would look like is, okay, y, which the y is 0, is 0 less than 2/3 times the x, which the x is 4, minus 1. Is this a true statement? Well, 2/3 times 4 would be 8/3, okay? And then 8/3 minus 1 is 5/3. So is 0 less than 5/3? Yes, it is. So it's a true statement. That is all that we're saying. And so I know I shaded correctly. If I picked this point and plugged it in, it would still be true. This point, it would still be true. If I picked any point over here that's not shaded, so here's a random point that's not shaded. If I picked this point and plugged it into all this, guess what would happen? It would be a false statement. So whatever number was here would not be less than whatever number is there. And so that's why it's not part of the solution set. So these questions, these inequalities, we've already mentioned it before, they have an infinite number of solutions. And what you're doing on a graph here is you're shading where all of the solutions exist. So now we're going to do the same thing but with this equation. Now this is already bad because it's hard to graph because we need it in y equals mx plus b form. So the first thing I'm going to do is just rearrange this. Let me subtract 3x from both sides. I'm going to bring this down, so this will be a negative y is greater than or equal to, I've got a 1 and a minus 3x, okay? Remember, you cannot put them together because one has an x and one doesn't. So you just recopy it, and I told you last week why I like to write it this way. Now what? Now there's a negative on that y. We need to get the negative off the y. So now we divide everybody by negative 1. Now what happens when you divide everybody by a negative? Remember, the sign in the middle, the inequality in the middle, has to turn the other way. It has to flip. And that's one of the rules that we wrote above. 3x minus 1. So that should be correct now. A negative divided by a negative is a positive. Positive divided by a negative is a negative. And this is what our problem will look like. So now let's graph it. I need to start at negative 1, just like I did on the last one. My slope is 3 over 1. So up 1, 2, 3, and over 1, 1, 2, 3, over 1, or I could go down 3, left 1. Okay, solid or dashed, what do you think? We need to look here for that answer. It better be solid because there is a solid equals underneath that. So solid line. And then I need to shade. So this is a y is less than all of this. So if y is less than all of that, I need to shade below the line. So below, if you have a hard time with above and below, just think greater than, less than, you know. Below this line would be whatever's under it. So it's going to be all of that, just like the one that was over here. So if you want to check an answer, pick any point here. I'll pick... Let me pick 3, -2. So I'm picking the point 3, -2. Let's plug it in here and see if it works, okay? So the -2 is the y, less than or equal to 3 times 3 minus 1. This better be a true statement, and that'll tell me that I shaded it correctly. So is -2 less than or equal to, what is that, 9 minus 1, 8? Yes, -2 is less than or equal to 8, so I know I shaded it correctly. All right, cool. So on to the next example. Okay, the next example is that we're going to extend this to the same thing you did last week, solving a system. So now, instead of it being an equals, it's going to be greater, it's going to be an inequality. So there's going to be some shading involved. Now, this is going to be, you're going to do everything the same as last week. The only thing here is to keep in mind the answer is a little different. The answer last week was one point where they intersected. This week the answer is going to be where the shaded part intersects. Okay, so let's graph them both and then you'll see what I'm talking about. Okay, I'm going to do the first one in red. Okay, now y is less than, okay, this is already in mx plus b form, so it's good to go. So I start at 3. 1, 2, 3, and my slope is a -1, which is -1 over 1, which means down 1, right 1. Now, do I shade with a solid or a dashed? Well, that symbol tells me to shade with just a dashed, and you can look above if you don't know what I'm referring to here. Okay, and then it says y is less than, so I need to shade everything below this line. Okay, so however you want to shade, but it's got to be the shading below. So I'm just going to kind of, everything underneath the line. All right, so that's my answer to the first one. Now I have to graph the second one and see where the shaded parts intersect. So how do I do that? Well, first, this is not in y equals mx plus b. And so I need to fix that. So let me subtract the x from both sides. Bring that down. It's a 2y greater than or equal to. Now these don't go together, right? One's got an x and one doesn't, so just recopy it. Now what? Now the 2 on the y is a problem, so let's divide by 2. Now when you divide everybody by 2, do I need to switch the symbol in the middle? The answer is no, because it's positive. So if you're dividing by a positive, you just leave it the same. And so the answer is y is greater than or equal to negative. I'm going to go ahead and put that 1 in there so that we can see the slope is 1/2. -1x over 2 plus 6 over 2 is 3. All right, cool. So here's my new equation just by rearranging it. I'm going to graph this. So I need to start at 3, so start at the same spot as here. And my slope is now down 1 and over 2. Or up 1 and left 2. Now this one has, the symbol has a little equal to underneath it, which means I need to do a solid line. And it says y is greater than or equal to this. So that means I'm supposed to shade above the blue line because it's a greater than. So I need to shade above the blue line. Now, the answer to this system is going to be anything where the shading intersects, and it's sometimes hard to see. I'm liking that I use 2 different colors because I can see it on my picture. If you can't see it on your picture, it just means maybe shade a little darker on one so that you can see where they intersect. I'm not really sure what to tell you. Color is probably the best for now. So if you've got map colors at home, feel free to do that. But I see that these shadings overlap right in here. So between this red one and this blue one is where my shadings overlapped. So I'm going to make a point to say that my answer is anything in there. And your picture is your answer. So if you're like, well, how do I write the answer? This is how you write the answer. The picture is the answer. So if your teacher says, find a point that is a solution to the system, if you find any point up in here, you're fine. So let's see, let's do like, what's something that's like right there? How about -4 and the point -4/6 should work. So an example would be like, you could tell your teacher, okay, well -4 is part of the solution set, but please understand that's not the only solution. There's an infinite number of solutions because it's anything inside of the green. But if you take that point that's inside the green, what would happen is if you plug it in to both equations, it would be true in both equations. So example, the point blah 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 would make both equations, or I should put inequalities, true. And that's how you know that you've done it right. And you can go check it if you want. I have faith that we did this the right way, so I'm not really going to check it, but you can if you like. And that's how you do it, folks. So have fun on the homework, lots of graphing, lots of little details to pay attention to, and we will see you in the solution video to see how you handled it all.